Okay, so camera's on now. Okay, so we have a graph of live value in dollars. Maybe it's your bank account, maybe it's your smartphone, maybe it's your vehicle. Hope it's worth more than $600 if it's your vehicle. You're gonna be looking at some repairs, I think. Okay, so anyhow, T is time in months. And maybe it's the month of the year. T goes from 0 to 12, okay, whatever. Okay, the 0.2600 would mean, and everybody seems to understand this pretty well, that at time T equals 2 months, because that's what the 2 is, the value is $600. Okay? And let's say now that at T, well, let's say you got a point here. Let's say your value is going up. So it's probably not your vehicle, probably not your smartphone. The value is going up, and at 7 months, it's 1,100. Well, that means that at 7 months, your value is $1,100, right? Okay, so let me just ask you this question. How fast is the value changing per month? Well, how much does the value change? Yeah, you can give me fingers in hundreds of dollars. How many $100 did the value change? Okay, well, started at 600, right? You ended at 1,100. So $500, right? Okay. Changed by 500. That's from 600 to 1,100. Now, what else do you need to know to figure out how quickly it's changing? Well, if you change the value by $500 in 2 months, it's changing faster than if you change by $500 in, say, 9 months, right? The shorter the time that $500 takes to change, okay, the more quickly it's changing, and the answer to your question here is going to be greater, okay? That is, shorter time, quicker change, okay? Longer time, slower change. Well, how much time did it take? How long did it take? Months, right? So at least on the average, well, how much change is that per month? In hundreds. That's $100 per month. So value changed at $100 per month. Pretty simple, right? Okay. Now let's see how this is related to slope. Well, just draw this triangle. You don't have to copy down everything in the board, so we want to do this quickly. Just copy this triangle, include the 2 600 and the 7 1100, and fill in what's the rise and what's the run. Nothing more than just a triangle, the coordinates, the rise and the run. Okay, you want to figure the whole darn thing? Not a bad idea. Sounds good. Okay. Okay, so I think everybody sees that the rise is 500, meaning $500, and the run is 5, meaning 5 months. Okay? So the slope is $500 over 5 months. I'll write it as $100 per month. The slope of the graph represents how quickly the amount of money is changing. So the big deal is the slope represents the average rate of change. The average rate of change of what? Average rate of change of the value with respect to time. I'll say that's the average rate of change of y equals value with respect to time. So when you get to the section on applications of slopes, that's your paradigm example. Now if it's something besides value and time, okay, let's say I'm tracking my weight. Okay, if my weight goes from 170 pounds to 160 pounds in 5 months, between, let's say, February and whatever is 5 months after February, is that June or July? That'd be July, right? Then you could do the same thing. You could first represent the February weight as month 2, 160, 170, okay? And the July weight as seventh month, 160. And you get a slope, which would be how much my weight is changing per month. That's down 10 pounds in 5 months. That's 2 pounds a month, right? Okay? And of course, it's negative 2 pounds per month, meaning that I would have been losing weight, okay? On the other hand, if I went from 160 to 180 in that time, I'd be gaining 4 pounds a month, right? So these interpretations are important because, well, that's why this is important. Now we could go much further with this. I'll just give you a little preview of what you would see. Sometimes kind of reinforcing the stuff you're seeing for calculus. Let's say this is a curve that represents my weight or whatever, okay? Or a value, okay? Or something. The slope of this curve at each point, well, the slope changes. Is the slope increasing or decreasing? Tell me, increasing or decreasing? Is it getting steeper and steeper, or is it getting less and less steep? So the slope is decreasing. The value is increasing. The slope is decreasing, right? And you might have seen this in Mr. Gallagher's class. That means that the graph will be concave down. Okay? Value is increasing, but the slope is decreasing. The slope could be represented by a tangent line at each point. And that's a line that just touches the curve at that one point, okay? And we see how the slopes are decreasing. So if it's my weight, it means I'm increasing at a slower and slower rate, okay? Maybe I've been sick and maybe I'm approaching my ideal weight again. Maybe I've lost weight and I'm approaching whatever my ideal weight is, but approach it more and more slowly because I don't want to keep eating like a horse and overshoot. Okay? Make sense? Okay, just a little aside there, but gives you a little bit more, hopefully a little more motivation to understand graphs and slopes. Okay? Very, very important. And central slopes are basically the first of the two central concepts in calculus. Pre-calculus being preparation for calculus. So the ultimate goal is calculus. Unless you want to be an engineer or something, in which case you got calculus and you got calculus with a huge attitude. Okay? And that's the minimum. Most people aren't aiming at that. Most people probably aiming at something like a semester or two of applied calculus, which is easier than the engineering calculus. Okay.